16 said? Alright, 15 comes first, so we'll do that one. So we got the acceleration of particle moving along the x-axis is given by a of t equals 12t minus 10. So we have a variable acceleration here. So it's time 0, the velocity is 3, the position is 4. What's the position at time 2? We can work our way backwards here by anti-differentiating to get from acceleration to velocity. So it would be what, 6t squared minus 10t plus c. And with our initial condition of 0, 3, we'd have c equals 3. So that means our velocity equation then would become 6t squared minus 10t plus 3. And then our position equation, we can do the same thing. Okay, we'd get 2t cubed minus 5t squared plus 3t plus c. And they told us our initial position was 2. So if our initial position is, or not 2, but 4 at time 1, I guess, is what the condition is. So 4 at time 1 will give us 2 minus 5 plus 3 plus c, which would ultimately give us 0 for the right-hand side plus c. So that means our position equation would be 2t cubed minus 5t squared plus 3t plus 4. And now we want the position at time 2. So putting a 2 in here would give us 8. 8 times 2 would give us 16. Putting a 2 in there would give us 4. 4 times 5 would be 20. Putting a 2 in here would give us 6. So we'd ultimately have a final answer of 6. And that'll do it. Questions on that one? Alright. 16, yay or nay? Huh? Says that we got differentiable functions. The differentiable function f, which is the following, is true for any real numbers a and b. And the question in number 1 is that if we have the integral from 2 to a of f of x, if that's equal to 2 to b plus b to a of that same function. Alright, so again it says which of the following must be true for any real numbers a and b here. Okay. Alright. So if we look at our choices, or our choice on this ultimately is going to be to decide whether, using our properties of exponents, whether or not this is true. Okay? So what I would suggest is that if you subtract this one to the other side, your sentence would read 2 to a minus 2 to b. And ultimately that is, if I go 2 to a and I switch this, go b to 2, okay? Ultimately that right there, okay, is kind of backwards of where I want to be. Okay? What would be best here would be to, if I want to go, have 2 be essentially the value that's between these two. Okay? If I wanted to, instead of going that way, if I switch these two around, okay, I would have a to 2, make that one negative. Okay? And now we're getting something that looks like what we want. We're going from a to 2 and then 2 to b. We know that that's equal to, if these were both positive, that would equal from a to b, if you will. Okay? And keep in mind that right now our sentence reads that at this point. True? Oh, I lied. Wrong one. It would read that. Okay. All right. And so, with that said, if we were to decide whether this was true or not, okay, we could essentially put these two on the other side, and we'd have this one plus this one equals, and this one over here would be the opposite of a to b. And nope, I lied. I still screwed it up. This is b to a. Okay. All right. So if we write the thing down right, that would be helpful first. So let's switch sides. If we switch sides, then we'd have negative b to a. Still Right that time. Jeez. So negative b to a over there. On this side we'd have a to 2 plus 2 to b. Alright, and ultimately on this side, remember this side equals from a to 2 and 2 to b. Okay, that would ultimately just be the addition of the area from a to 2 and the area of 2 to b, which ultimately would be the area from a to b, wouldn't it? And so what do we have on this side? We have the area of b to a, but it's the opposite of that, which ultimately this equals what? Equals the area from a to b. So the long way to get to it, the answer is yes, that's true, isn't it? All right.
It'd be wrong to just draw pictures.
Are they going to look at your work?
No.
So is it wrong to do that then?
It's not.
Nope. As long as you mark the right bubble, they don't really care how you do it. All right, and then the next one, number 2, it says the integral from a to b of 3 f of x is the same as 3 times the integral of just f of x. We know that's true. You can factor out a constant multiple, so 2 is also true. And then if we look at number 3, they evaluated the integral. Okay, they have f of x as our integrand squared, and so ultimately the that's just completely wrong, basically. I mean, we know that if we were to try to anti-differentiate that f of x all squared function, okay, we don't just put b into that and then a into the other part and square it, do we? So 3 is no good, so 2 and 1 only, which would be C. All right, next. All right, on 18 we have limit as h approaches 0. We got an h on the bottom, so it already looks like a derivative here. And so what are we putting our x plus h and our x into on top? What function are we putting them into? Yeah, this is just f of x equals x squared, isn't it? Okay. So the question is, what does g of x equal, or for what value of x does g of x equal to? Okay. Well, remember, g of x is the derivative, okay, of the function in question here. So g of x is ultimately equal to what? It's equal to 2x. Okay. All right. Remember, g of x is defined as this. This is the derivative of x squared. Okay. So g of x is the derivative of x squared. So therefore, the question is, when does g of x equal to? If b of x equals what? Questions? All right, this is g right here. Okay. And what is g? That right there is the derivative of f. This is the derivative of x squared. So g equals the derivative of x squared. So therefore g equals 2x. Ultimately, what function are we putting into our limit definition is what I said. So f of x is x squared. This is the derivative of x squared. You don't really have to call it f of x if you don't want to. Just recognize that right there is the derivative of x squared. So therefore, what does g of x equal? It equals 2x, the derivative of x squared. All right.